Okey, Assalamualaikum dan selamat pagi semua. Khabar? Morning. Hi, morning. Okey, antara korang siapa yang dah ada di UTM? Ramai tak? Melbourne ada UTM. Siapa ada UTM lagi? Eng ada kat UTM. Okey, lagi siapa? Yang lain kat rumah Ting berada kat UTM. Alright. So, semalam Dr. Afiq dan saya pun dah ada bagi briefing tentang apa yang kita akan belajar, kaedah apa yang kita akan guna untuk belajar. Okay, Zulmi pun ada kat UTM Right. Okay, so semalam saya rasa lebih kurang semua dah faham lah macam mana kita punya course separation method. So saya pun akan menggunakan kedua-dua bahasa lah sebab nota kita bahasa Inggeris, okay, English, dan semua dalam ni rakyat Malaysia berbilang kaum. So kita akan rojak bahasa rojak English and Malay. Right. So separation methods, SSCC3243 ataupun sebelum ni ada 3283 kod dia, right? So the first part of this topic of this course, estimately about 6 chapter, I think. Saya akan ajar, okay, on the introduction, on the theory, alright. So on the practical part, will be taught by will be teach by Dr. Afiq lah. Okey. Sebelum tu kita nak mulakan kelas kita dengan prayer masing-masing Kita ada pelbagai agama dalam ni. So we start our lecture with your own prayer. Okey, bagi agama Islam, kita mulakan dengan Al-Fatihah. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin, arrahmanirrahim. Maliki yaumiddin, iyyaka na'budu wa iyyaka nasta'in, ihdinas siratal mustaqim, siratal ladzina an'amta 'alaihim, ghairil maghdubi 'alaihim waladdallin. Amin. Okay, so kelas kita pada hari ini, hari Rabu pagi lah pukul 8 lagi kita dah ada kelas. Dan memang kita akan start betul-betul habiskan chapter ni kalau boleh lagi awal lagi bagus. Sebab nanti kan ada puasa lah raya lah, jadi kita nak smoothly lah kita punya lecture ni sebab SEM ni agak pendek SEM ni agak pendek, so kita agak berkejar sikit lah. Right, so introduction for the separation methods. Alright, okay, I am Dr. Faizuan Abdullah, Senior Lecturer, Department of Chemistry, UTM. That is my email. Okay, nanti bila dah masuk ke UTM, my room is at C10341, right? As in the course information. Alright, so this note actually prepared by Dr. Amy because previously she taught this course. So me and Dr. Afiq, this is our first time lah. But we are in the analytical chemistry panel, so we are familiar with this separation method and so on. But it is our first time to teach it, to teach this course in the in the proper course lah, in the proper in a structured academic course, right? So as a synopsis, this course introduced the basic principle, instrumentations, and focus on application of separation methods commonly used in chemical analysis. A general overview and classification of common separation methods is first given, followed by their basic principle of separation. Major separation methods and their application discussed include extraction, chromatography, and also electrophoresis. So when we talk about the separation, mostly it's about extraction, chromatography, and electrophoresis, right? In the mostly in chromatography method, alright, in the separation method lah, yang instrumen yang melibatkan HPLC, GC, apa lagi TLC kan, yang kita pernah belajar dulu kan masa SSCC3243, betul tak? Betul tak? Kau belum belajar? 2243 kita dah masuk belum ke chapter-chapter yang melibatkan ni kan, betul tak? Okay, Melissa cakap yes, doktor. Alright. So, chat tu you boleh set tau. You boleh pergi ke to everyone ataupun to personal. Right? Alright, industrial scale analytical separation will also be briefly introduced. Eng, your Webex cannot chat to everyone. Tak apalah. Chat to me pun okay lah. Right? Alright, so guys, for your information, these separation methods, okay, are very, you know, the application of this technique, of these instruments involved in the separation methods are widely applied in the industry. If you master, right, if you understand well, right, so you need to stay focused lah with the class and so on. So of course you need to understand, all right, separation methods, chromatography method, because this is widely used in the industries. Okay, you dah tahun 3, next year tahun 4, tak lama pun. After that we will release you to the world, all right, to the industry, okay, to the government and so on, because the separation methods, all right, in chemistry is widely applied in the industry, government, and so on, right? So you need to know, not only to know, but also to understand, right? And it is really good for you to master this thing, right? Because as I said, you will see all those instruments, okay, in the industries as well as the government labs, right? So right, industrial scale analytical separation will also be briefly introduced. Right. As a housekeeping, okay, we have our class rep, right? Who is our class rep? Fifa, if I'm not mistaken, right? Is it true?
Yes,
Fifa
Doctor.
here? All right,
Yes,
good.
yes.
Oh, tak ada kat tepi jalan hari ni Fifa Ada kat dalam rumah
Kalau Doktor nak saya pasang lagu boleh juga.
Jangan. Nanti kita tak ada kelas, kita karaoke beramai-ramai. Jangan Right. So class attendance, right guys, I need to remind you need to attend our class. I said our lah because me and Dr. Afiq, alright? 80% above, right? Means you can only be absent with or without letter for about how many hours? 8.4 hours, right? But please lah, kalau tak dapat datang, okay, you have any problem, don't make it, don't make it silent lah. Jangan tak bagi tahu orang. At least you tell your class rep, or of course you need to tell us lah, me and Dr. Afiq, okay? Whatever problem that you have, okay, please, okay? We as a lecturers, we are really concerned about you. You all je tak tahu kan, kita meeting kan, you all ada masalah pun kita bincang, right? You tak ada internet ke, you apa semua kita bincangkan. And we try our best to help you, whatever it is, alright? You have for your PAs and so on, but please tell us whatever problem that you have. Tak perlu bagi tahu dalam kelas pun, you tell us personally, right? So 80% above. Only MC issued by PKU and government clinic is allowed, right? 2 kali is allowed. Nak cakapnya betapa allowednya PKU dan government clinic, right? Ignore the mistake in the sentence lah, but the most important thing, the MC issued by the government clinic or pusat kesihatan university, right? Why? Because no lah, private can buy one lah, right? So student cannot sign the attendance. Oh, for our case, online class can lah. Okay, if he or she comes late 20 minutes, but up to you to stay in the class, right? This is a common rule lah. Siapa tak scan attendance lagi tadi? Saya tutup awal 5 minit tak apa. Nanti at the end of the class saya akan buka lagi lah. No worry about that lah because we are online class, right? But if you come 20 minutes or you need to give us some reason lah why you come 20 minutes or above late, right? And then we have given the course information, right, in the e-learning. Have you read it? Right, you need to read it. Okay, memang you all kena baca course information. Apa yang akan korang belajar bila test, apa test, soalan macam mana Test malam kita dah bagi tahu test up to what chapter? Semalam dah bagi tahu. Siapa yang ada semalam, dia orang mesti ingat. Test sampai chapter mana? Sample prep. Okay, chapter 5. Alright, good. Alright, and bring at least, oh ni korang bawa marker dalam kelas pun saya tak nampak pun sebenarnya. So this is used for face-to-face class lah. Rindu tak nak datang face-to-face class? Rindu tak? Rindu tak? Rindu tak nak datang UTM? For face-to-face class. Makan kat Akik Meranti kan? Kena saman dengan Pak Gad. Okay? Kena marah tak pakai kasut kat lab. Rindu tak? Okay? Pak Vitran rindu. F2F kan? Okay? Rindu kan UTM kan? Dulu korang nak balik rumah selalu kan? Kan rindu pula UTM. Itulah. Lain kali jangan benci nak datang UTM. Right? Benci tapi rindu. Alright, so ensure your phone can be connected to the internet in each class. Of course lah, now we are online class. Of course lah, you need to have internet. Okay. Apa ni? No WhatsApp, no tweeting. Ni saya tak nampak. Tapi please focus lah in our class. No social media lah. Tiba-tiba upload nak selfie masuk ke Instagram sambil kelas. Tak payahlah. Focus in our class. Okay. Your parents send you to study lah, not to tweet during class. Tengok tu. No laptop in every class. In our case, we need to have laptop lah. Ignore this one lah. Okay. So, alright. Basically, conventional class, saya cakap depan seorang-seorang, you all dengar, it's very boring lah. It's very, not up to date lah, that type of class. Saya bercakap seorang, you all dengar, tidur kan. Terbongkang kat situ, tak kata tak boleh. We need to have active learning. Either we are in the online mode. Okay, I try my best lah to do some active learning. You know active learning, right? Not only I'm speaking in front lonely. Okay, and then you hear, I don't know you hear or not. Okay, but we need to do some activities in our class, right? To make it more interesting. Okay, you can remember or you can understand well, right? See there where what I hear I forget. Okay, what I see I remember, but what I do I will understand, right? That's why we need to have some activity. All right. Oops, sorry. All right. See there the learning pyramid knowledge retention rates, right? You see there lecture 5% je masuk, right? If you read you will get 10%. That what we call audio or visual 20%, demonstration 30. Okay, both 30 to 5% we call as a passive teaching method, right? And then we have participatory teaching method. You participate in the teaching process. Okay, what is those activities that involve in participatory teaching method? Discussion group, of course, you get 50%, okay, of the knowledge. And then you when we do practice by doing, all right, you will get 75% of the knowledge. And if you teach others like me now, I'm teaching you, okay, I will get 90%. So I'm the most I'm the one who really understand the knowledge because I teach you, right? So if you want to understand, You need to teach us, okay? You need to teach, you know what we do is peer teaching, right? In our class. We will do some activities lah. We try our best lah, right? Adapted from national training laboratories. How to spell, how to pronounce that, mind. Okay. Okay, remember these Three Idiots, right? Good movie. This is Mr. Bean. Okay, this is all you lah ni kan. Datang kelas untuk tidur. Right. Sebenarnya dia tengah belajar dalam alam mimpi. Okay. This is what we do in active learning. Okay. We are discussing about the topics and so on, activities. All right. We need to present. We need to do some, you know, we give suggestion our group and so on. This is active learning. Yeah, okay. Then we present to others. This is peer teaching. Okay, you teach your friend in the class. Okay, but with the lecturer guidance lah. Okay. Actually, for those who learn with me, SSCC3243, I've done so many activities. Right. It is interesting to learn with me in the class, guys. For those who already take the course with me, can you share your experience? I need one lah. Melbourne, can you speak now, Melbourne? Share your experience with us. Macam mana saya handle kelas SSCC 2243 dulu? Is it interesting or not? Melbourne, are you here, Melbourne?
Good morning semua.
Morning, yes. Share your experience.
Experience face to face ke doktor?
Yes lah, face to face. Masa face to face lah sebelum pandemik.
Oh, masa tu memang masa sebelum online class memang macam biasa je lah, macam kelas biasa face to face. Tapi bila dah masuk online class tu macam memang rasa rindu lah nak kelas face to face tu. Sebab dapat tengok alat-alat.
We have activities or not during our face to face? Melbourne?
Ada.
Do we have activities during our face to face? Okay, what kind of activities? Example. Melbourne dah hilang dah.
Hello, dengar tak?
Ya. Melbourne, apa aktiviti kita pernah buat?
Pengenalan instrumen untuk detect chemical yang macam dalam chemical dalam sea, like that lah. Ada beberapa instrumen yang dah belajar face to face yang doktor.
You still remember that we do some activities? You know, you wear a cap and so on.
Apa doktor?
Ni, you ingat tak aktiviti yang kita pakai topi tu? Different thinking hat.
That one. Ingat doktor, ingat.
Alright. What we do, different thinking hat, right? Kita pakai topi yang berbeza, warna untuk pelbagai role, betul tak?
Berbagai
ada
role,
polis, ada
satu case tapi pelbagai.
Satu case kita pelbagai role kan. So we learn a lot using active learning lah. Okay, rather than passive learning. Okay, this is example of the presentation. Alright, what do you have to prepare for active learning? Soalan lah, nota and so on. Okay, then we will do some of them lah yang sesuai untuk online lah. Alright. Alright. Ini sebenarnya kalau dalam kelas kita boleh buat dengan kawan-kawan sebelah lah, right? So the activity is, do you still remember, right? Recall the 9 steps in doing chemical analysis, alright? And B, find out how to do sampling on solid, liquid, and gas samples. Okay, I give only about 5 minutes. Okay, macam mana saya nak grouping kan, alright? For student A, I need boys, alright? So boys, okay. Pavitran lead the boys, alright? Recall the 9 steps in doing chemical analysis. Then you choose one of boys to recall the 9 step in doing chemical analysis. Okay. And then B for girls, find out how to do sampling on solid, liquid, and gas samples. This thing we have already learned. SSCC3243. All right. So I give you about 7 minutes lah. 7 minutes. All right. Gather boys A, girls B, and then choose your representative to just to present lah what you have discussed already after 7 minutes. Okay. Do it now. Okay, after 7 minutes, I will call. Okay. Okay, macam mana nak bincang? This is by your own strategy lah, right? Boys and girls. A boys, B girls. All right, guys, time's up. Okay. I need boys to present first lah. Choose your representative, okay? And then share about the recall the 9 step in doing chemical analysis. Okay, come on. Pavitran, siapa akan present?
Hello, good morning, doctor. Boleh dengar ke?
Hello. Hurry up,
Boleh
guys.
dengar ke, doktor? Good morning, doktor. Hello,
Slow,
doktor.
slow sikit. Siapa Pavitran ke tu?
Yes,
Kuat
saya.
sikit.
Boleh dengar ke, doktor? Boleh dengar ke, doktor?
Okay, boleh. Silakan. Ya, boleh.
Saya
Silakan.
panggil anyone, any of the guys,
Alright.
Okay, saya nak panggil Tan Gihan. Gihan, are you there, Gihan?
Yes. Hello.
Ah,
Can you hear me?
yeah, sure.
Yes.
Okay.
Please, yeah.
So the the first step is define a problem and then do some literature research about the topic. After that, select a suitable method for sampling
Okay.
and done the sampling and the pre-treatment of the sample such as preservation. After that, prepare your sample, eliminate all the interference that may occur, then carry out the analysis and data treatment. After that, compile everything in a full report. That's all.
Okay. Alright, good. Thank you, Gihan.
Okay. Well,
Okay, now. Okay, thank you, boys. Alright. Now we call girls, your representative. Find out how to do sampling on solid, liquid, and gas sample. For those who learn with me, SSCC3243, okay, I've taught everything about this. I bring the apparatus to the class, if you remember. Okay, come on, go. Okay, kau tak lantik siapa ketua tu kan? Afifah lah. Okay, siapa? Nak present.
Saya sebut Okay. Ada yang nak ni ke? Maksudnya nak volunteer? Kan nak saya sebut?
Up to you.
Okay. Michelle Lee Messi.
Michelle, okay.
For the solid sample, first we need to grab the sample according to if we want to grab sample or use composite sample. Then normally for the solid sample, we do the cloning and quartering method. Next, for the liquid sample, we need to collect the sample directly. For the homogeneous liquid, we just collect the sample directly. For the non-homogeneous, we need to use the machine. What name? One
Apa
machine.
tadi tak dengar mesin apa?
Machine. Got one machine got one machine that pusing, then dia akan homogeneous the liquid. Then last for the gas liquid, normally we just collect directly.
Okay. Girls yang lain ada tambah tak? Any member nak tambah? That's all. Okay. How you do sampling on solid? You remember we use a grab sampler, okay? And then if you remember, we do cone and quarter method, right? If liquid, we have water sampler, okay? Horizontal or vertical, okay? For gas sample, we have solvent, we have Tetlabet, canister, and so on. All right. Okay, thank you, boys and girls. Okay. Ni tadilah sepatutnya dalam kelas macam ni lah. Right? Okay,
Doktor
yeah.
nak tanya.
Alright.
Untuk sampel tiff kan, dekat
Yes,
sampling
sample tip.
liquid,
Alright.
dia ada banyak type kan doktor. Maksudnya jenis dia, polyprint apa tau, tu kan. So macam
Mana?
setiap tu dia
Example?
ada faktor.
Example? Jenis apa ada?
Alamak. Ingatlah pula. Tahun
Dia
lepas
banyak.
saya belajar. Tahun lepas. Maksudnya setiap sampel tiff tu dia berbeza ke ataupun macam kita boleh just pick, ambil lepas tu boleh guna ke macam mana?
Alright. Normally, okay, for water sample tiff tu, we have vertical or horizontal. Okay. For example, if we're gonna do some sampling for tube well, okay, the most suitable one if we will use the vertical one lah. Okay. Why we need a water sampler? Okay, water sampler, the mechanism is at certain depth. Okay, kita jatuhkan dia punya pemberat tu. Okay, and then the water will trap at that depth, at particular depth, right? Because at different depth of the water, okay, dalam sungai ke tasik ke, tube well ke, okay, tube well apa, perigi we have a certain water quality, different water quality, okay, dissolved oxygen, nutrient and so on. So we need to know at certain depth what is the let's say contaminants or the water quality itself at certain depth, right? So normally at when we do sampling at open sea or river, we use the horizontal one lah, okay, because ada arus, okay, open sea ke river semua ada arus, ada the water have current, okay, the water is moving, so we need to use the horizontal one, okay, to do the sampling at certain depth, right? And then itulah jenis, normally ada dua jenis lah, horizontal and vertical. Yang lain tu brand je sebenarnya, right? And also the size lah, size of the water sample, right? Okay, Fifah,
Okay,
right,
doktor.
this is some news lah about. Okay, apa lagi?
Sorry. Yang tadi doktor sebut untuk gaseous sampler tadi apa?
Gas,
Can
alright,
you
gas,
mention back?
okay.
3 tadi doktor sebut.
Okay, gas, normally we use, okay, just imagine, okay, you are like I was dealing with the Sungai Kim case before this. Okay, there's a very unique case where is some illegal chemical waste dumping at the Sungai Kim, and the chemical waste react with the water and release the volatile organic compound gas, okay, into the air, and the toxic gas move through in the open air, move by the wind, okay, to certain schools and so on. So how we gonna trap the air sample, okay, the air sample to gas lah, gas sample, right? We need to do kita kena ambil dalam satu macam bag close kan, close a closed container, okay, we go there, put take the air or the gas sample into a closed container. So normally we have that lah bag. This is a common method. Dia macam bag plastik. Kita pump the air masuk dalam tu dan kita seal. But it is not so good because air, the molecules, the gas, the molecules are very small and can penetrate, okay, the surface of from the surface of the plastic and so on. So it's not a really good method lah, but that is a conventional method. Okay, now we have a modern one. We have adsorbent, or we call it as sorbent. It's like a material, a tube. Okay, we have an adsorbent inside. We use a pump, okay, to pump the air, to flow the air into the sorbent, and then trap any of the toxic gases that we target inside this absorbent, and we bring it to the lab to the instrument, let's say the thermal desorption gas chromatography, right? And then it will detect what type of gas inside. Okay, it will dissolve and go into the column, and we detect what type of gas. So I will share with you, wait for a while. Nice question about gas, because kita jarang kan tengok macam mana sampling gas. Okay, wait for a while.
Maksudnya
Yes.
kan, Tetla bag tak pakai ke? Ke macam dia boleh pakai tapi tak conventional?
Tak, boleh pakai, murah, tapi it's not so good method lah sebenarnya. In the saya pun baru meeting 2 hari lepas dengan Jabatan Kimia Malaysia. We are discussing about sampling the air sample at the Pasir Gudang. So the government, after the Kim case, have bought the canister lah. Okay, one of the method that we have also canister. Okay, let me share with you canister. Wait for a while. Right guys, tengok sini Okay, this is the carbon sampler. Wait, I show to you the canister first lah. Okay, this is a canister. Okay, instead of using plastic, we are using a stainless steel. Okay, container to trap the gas. Okay, and then we close the valve. We pump the air inside. Okay, and then we close the valve so that the air that we sample from certain places will trap in this canister. We call it as canister, and then we will bring it to the lab. The gas sample will retain longer in this canister rather than we use plastic bag, or we use Tetla bag, we call it. Okay, that is a conventional method. So the canister is the is the suitable one lah. The method is better than using plastic. So we have canister right now, but one of the canister costs about 5,000. Okay. Alright, this is the solvent. Okay, dia macam satu tube je, dalam tu ada absorbent lah, maybe carbon, silica, zeolite, depend on the type of gas that we're going to sample. Okay, and then we pump the air. Look at this at the right side of the screen, okay, you see we have we need to pump the air, okay, inside the solvent, so that we will ensure that a lot of air volume being pumped, so that the analyte that gonna trap on the solvent is enough lah for us to analyze in the lab. Okay, so this is how we sample a gas sample, right? Okay, boleh faham?
Boleh. Doktor,
Alright,
kalau macam apa, macam waktu analytical dulu, kita orang ada belajar high volume dengan low volume sampler. Yang tu apa?
high volume. Macam mana high volume? High
Dengar
volume, low
tak?
volume.
Tak dengar.
Yes. High volume, low volume. Macam mana? Macam mana you boleh share? What type high volume macam mana tu?
Dia cakap, kita orang belajar dulu, dia untuk macam kalau total suspended particles yang more
Okay.
ataupun less than 10 micrometer akan guna benda tu.
Okay,
Macam
that is for the particulate matter, PM. We have PM10, PM2.5. PM is not gas. Actually, we sample the air, but to calculate the PM, the particulate matter, is a solid in the air. Kalau jerebu, ingat tak jerebu kan? Kita nampak kabur kan? Kerana particulate matter tu, hasil pembakaran terbuka tu, okay, dia punya abu, dia punya apa nama ni, di inilah ashes kan. Dia berterbangan di udara, so that kita akan nampak udara tu ni kan tercemar kan, macam asap kan, terkabur pandangan kita, sebab itu bukan gas sebenarnya. Memang dia juga satu pencemaran udara. Okay, we need to sample the gas to analyze the particulate matter, but the pollutant itself is not a gas, it's a solid. We call it as particulate matter. Okay, we have size lah of the particulate matter. Normally the indicator that previously Malaysia used PM10. Okay, particulate matter 10. What is a 10? Okay, we Google that. Tengok PM10. Right. PM10 air quality. Right. Okay. Maksudnya the particulate matter diameter is 10 micron. Right. And also we have PM 2.5. Okay, so the particulate matter is, the diameter of the particulate matter is 2.5 micrometer, microns, right? Previously we used PM10 as the indicator in Malaysia, but PM10 is really bad lah. Takkanlah particulate matter size 10 micron baru kita nak measure kan. So we have reduced the size of the particulate matter measurement for the air quality to 2.5, because Singapore is using 2.5 micron, meaning that we detect smaller than 10 particulate matter to indicate the air pollution. Faham Syifah faham? Yang lain faham?
betul. Just to
Yes.
be clear lah, maksudnya kalau yang kita belajar tadi tu, yang solvent, Tekla bag semua tu, dia punya pollutant ataupun punya analyte dia in gaseous phase. Kalau guna high
Yes.
vol semua tu untuk PM10 tu, dia punya
Itu untuk dia
analyte
punya
dia
pollutant
in
adalah
solid.
solid. Yes.
Oh, faham. Oh, maksudnya kita still bawa dia masuk lab ke? Kalau nak ukur PM10 ni ke macam on the spot?
Tak. On the sampling site lah. Katakan Johor Bahru jerebu. Okay, saya kalau ada jerebu, kita bawa lah indicator tu. Saya tak faham high volume dengan low volume tadi. Nanti boleh bagi dalam WhatsApp group ke nanti. What is the example Sebab
boleh. Okay.
yang saya faham itu adalah untuk particulate matter lah, untuk jerebu. Solid pollutants in the air. But we also have gas pollutants in the air, macam volatile organic compounds, okay, toxic gases lah So that is how to sample. We use previously the Tekla bag, the plastic bag tu. Okay, Tekla. You want to know the spelling Okay, Tekla bag.
Yang mana?
Okay, saya type dekat
Ted
WhatsApp.
Labek.
Dekat WhatsApp, dekat chat TED-LAR Ted Labek.
Yeah.
So this is the conventional method lah, previous method that not so good lah, not so accurate, because when we bring the Ted Labek after sampling to the lab, okay, normally the percentage of the pollutant inside the bag is decreasing lah, right? So the most proper one when we dealing with Kim case previously last 2 years, okay, the most proper method of sampling is using canister, right? It will retain longer in the canister. Of course lah, the gas cannot penetrate the stainless steel wall, okay, because the structure, the structure of the stainless steel, element or atoms is really close packed kan, gas tu tak boleh nak penetrate, right? So it will retain longer rather than plastic bag. And then if we are targeting some kind of gases, then we use solvent. Okay, we use solvent because the solvent itself, we have specific type of solvent for specific type of gas, and then we just pump the air at the sampling site into the solvent, inside the solvent, so that we can absorb the target gases on the solvent, and then we dissolve back in the lab. Okay, all right, understood? Refresh balik. Okay, actually the analytical chemist, we have a lot of job opportunities. Okay, banyak industri yang nak hire analytical chemist. Okay, industry demand for analytical chemists is growing, but some worry whether the academic pipeline can keep pace. Okay, meaning that are we ready to release you to the real world outside with the good understanding in the analytical chemistry knowledge. So that's why I told you this is very important, because outside there, analytical chemist is really needed. Okay, see that in the American Chemical Society, one of the most highest degree of the member, percentage of the member is from analytical chemistry background. Okay, so why separation methods? Okay, term and definition, classification, chromatography and related techniques, separation technologies, okay, chromatography market analysis, and so on. Okay, all right. Now, operation by which a mixture is divided into at least two fractions having different composition. Okay, that is a basic thing of separation. Okay, we separate. The key word is separate. We have a mixture and we want to separate, of course. Okay, so how are we going to separate? Okay, by forces. What is forces? Mechanical forces. Okay, or we do physical means. Okay, and then we have ... we have line there, reaction. Okay, what is that? We have a blank space there, and then reaction. Chemical reaction. Okay, good.
Chemical.
Okay, good, everyone. Good. Okay, good. Chemical reaction. So separation forces can be done by mechanical, physical, okay, and also the chemical reaction. So analyte in mixture, okay, can be separated due to different in size, volatility, polarity, solubility, and blank space strength. Okay, what strength? You remember, this is how the basic thing in separating in the chromatography technique. Okay, if you want to separate, okay, the molecules or the compounds, okay, we can separate it in several ways, such as the size. Okay, we have size exclusion chromatography, right? Okay, we have volatility, different volatility. Normally in the gas chromatography, right, we set the temperature due to the boiling point. Okay, so that is, we can also separate the compounds using volatility. So we can separate also with the polarity. Okay, polar or non-polar, right? We have a polar column, non-polar column, polar eluent, non-polar eluent. Remember that. Okay, we also have solubility. Okay, and we have blank space strength. What is that? Remember? Yes, Melissa. Ionic strength. Okay, different ionic strength. Okay, we can separate compounds based on the different in the ionic strength of the compounds. Good, right? Right, separation, or in Malay pemisahan. Okay, we have a mixture there at the right side, at the left side of the slide. Okay, red circle and also the yellow what? Square. Okay. That is a mixture of the molecule of the compounds. Then we need to separate. Okay. Either in one of the ways. Okay. Size, volatility, polarity, solubility, ionic strength, etc., etc. And then now, tada! At the right side we have separate the compound. So we have a lot of method in separation to separate the mixture of the compounds. Right. So why separation methods? Okay, the need for pure material engineering application. Okay, of course, we the industries. Okay, demanding for the pure materials in everything. Okay, in the food processing, in the chemical processing, in the what kind of things in this world get produced by industry. They need a really high priority, right? In the semiconductors industry and so on. So to get the pure material, of course, we need to separate it. Separate what? Separate the any contaminants, impurities. Okay, the word impurities itself meaning that we need to separate to get the pure one. So we separate the impurities, okay, outside from the pure material so that we can have a really pure material. That is separation. So preparation of raw materials into their components. Also, we need separation methods. Right? And then we need for pure materials, for material processing, of course. Okay. And then we need to remove toxins or inactive components from solution. For example, if we want to prepare drugs, okay, for a pharmaceutical industry, right? So we need to remove the toxins and inactive compound that we don't want in the drugs, in the pharmaceutical, in the medicine, for example. So we need to do separation method to remove all these toxin and inactive components. And then we need to produce ultra pure sample from testing. Also, we need separation methods. And then we need to analyze of the component from the mixture. For example, DNA testing. Now we have the COVID-19 pandemic. We need to do a really accurate and fast method to detect the DNA of the COVID-19 virus so that we have a good separation techniques also being applied, okay, to do the DNA testing. A lot of application for the separation methods, right? So why are separation techniques important for an analytical chemist? Okay, because it helps chemists analyze the substance under consideration. It also helps to obtain that substance for use. Separation is also used to purify and characterize the substance, right? And then this is an essential technique in industry to set the standards for evaluation of other substance, right? And then the main area of separations, analytical separation, is small scale and quantitative analysis. We have also preparative separation, small scale material for R&D, and then we have industrial separation, very large scale, okay? And we need to do it with economically consideration, right? Examples, right? So we have a common step in chemical analysis, okay? Selection and preparation of sample, determination of mass or volume of samples, right? A dissolution of the samples, a pre-treatment of the sample, okay? This is important, pre-treatment, okay? Adjust the pH, complex agent, oxidation, and so on, etc. And then we have isolation of blank space or interfering substance, okay? What is that blank space, or we call as interfering substance that I said? Matrix, yes, can, but the most important things, matrix, also we can call it. What is another name of that? The thing that we don't want in our sample. We need a pure sample, so we remove what? Interference. Yes, quite correct. Okay. Contaminants. Okay, good, close. Yes, the word is impurities. Okay. The words is to all of that, contaminants, matrix, and so on. We call it as impurity. We call it as impurities. because we need a pure one, right? Because it will interfere, right? Good, everyone. Okay, so measurement of analyte of interest, and then last one we have analysis of data and interpretation of the results. Okay, before we analyze, we need to do all those things: selection good method, right, or preparation method, determination of mass or volume of the sample, okay, dissolution of the sample, pre-treatment, okay, like pH adjustment and so on, and then we have to isolate, remove out all the impurities, and then we measure the analyte of interest, and then we analyze the data, and what we can get from the result, we interpret it. Okay, this is the common step in analyzing, okay, sample. This is the traditional step you saw at the kampong, okay, when the farmers, okay, the petani, okay, harvest the rice, okay, from the paddy field, okay. You eat rice, right? But do you know that the rice have you know the kulit beras tu, okay, chaff kan, adalah bahasa dia panggil apa kan, but this is the traditional method, okay. The farmers need to do that, okay, we call it in Malay, we call tampi kan. We you know, we shake the rubber apa ni, the bamboo made tampi tu yang that uncle pegang dengan auntie pegang tu, okay, and then shake it, okay, and then we make it up to the air, okay, and then the wind will separate the rice, okay, the separating grain, okay, grain from chaff tu kulit dia, okay, and then angin akan tolak dia punya kulit tu, then beras akan jatuh balik. So lama-lama berulang kali buat, lama-lama beras tu akan jadi tercabutlah kulit beras tu, dan you will get the pure rice. The rice without the cover, okay, the brown cover we call it chaff kan, kulit ataupun what we call that in Sabah, what we call that, Sarawak, what we call that, kulit beras tu. Have you done this? Okay, my mom used to do this before this. I saw my mom doing this. Okay, this is the separation method, separation techniques. All right, now this is a modern one. Okay, if you want to separate oil from water, we have some methods, okay, using separating funnel. Okay, we have the sieve, okay, to separate the size of the solids. Okay, we need for certain size, so and then we separate the larger size from the smaller size. Okay, and then okay, a separation science deal with the fundamental physical and chemical phenomena for separation and development and application of various separation process. Okay. Okay, term and definition. Okay, this is terminologies in separation method. Okay, we have partition. So the meaning of partition is partitioning of analytes between two phases while system approach equilibrium. Okay, and then we have distribution, refers to the distribution of analyte in the two different phases. Okay, distribution is refers to the distribution of analyte in the two different phases. What is the example? Okay, from liquid phases and a solid phases. Okay, so we distribute. Okay, and then we have the blank space. Okay, the meaning is distribution of analyte at the surface of the solid or liquid interface. Okay, meaning that this analyte will attach at the surface of the solid or liquid interface. What is it? Yes, Lim. Okay, Lim John. Tak nampak nama pun. Apa nama you? Lim Jong? Macam Korea je nama je. Lim Jun Chang kan? Lim Jun Chang. Okay, betul. Adsorption. Okay, AD not AB. Okay, adsorb. Okay, panggil JC je. Okay, JC. Wow. Very commercial name. Okay, JC. Okay, Siti Zuliana, Dr. How partition work? Okay, wait for a while. I will answer that. But I need to differentiate between adsorption and absorption first. Okay, so adsorption, our analyte will attach at the surface of the solid or liquid interface. But for absorption, distribution of analyte in the bulk space. Okay, it will be absorbed. Okay, absorb meaning that we cannot dissolve it anymore. If it is absorbed, it is remain there. But if it is adsorbed, AD, we can dissolve it back. Okay? Understood, eh? All right, so partitioning of analyte between two phases while system approaches equilibrium. So we will learn pink color, right there. So we will learn after this, okay? Detailing. So this is phase diagram of water. Okay, remember, okay, with the temperature, okay, there is a solid phase of the water. We have liquid, okay, we have vapor, okay, and then we have gas, okay, and then we have the dot there. What is TP? What is CP? What is TP and CP?
Triple point and critical point.
Apa?
Triple point and critical point.
Yes, triple point and critical point. Okay. Remember about the water. Yes, thank you, Irfan and Elaine and apa Siti Zuliana answering that. Okay. This is phase of equilibrium. Kan antara muka kan. Okay, schematic diagram of phase equilibrium. Okay, phase 1 and phase 2. We have A1 and A2, B1 and B2. So this is equilibrium. Remember equilibrium? The right and the left moving toward right and moving toward left is at the equilibrium at the same rate. Okay. The phase contact, the co-current, meaning that involving flow of material in the same direction. If the cross current, a current of water that flows against or across the main current. Okay, so it's cross current. Counter current and secondary flow that against or across the main flow. Okay, counter current. Right. Okay. The phase related to the separation methods. Okay. We have technique there and phase 1 and phase 2. Okay. Chromatography technique. Phase 1 is stationary phase and phase 2 is mobile phase. Okay. And then liquid extraction. We have phase 1 is raffinate and then extractant. Okay. We have dialysis. The phase 1 we call it residue. Okay. And the second phase is diffusate. Okay. You know what is dialysis? Can anybody tell me what is dialysis? What is dialysis? Have you heard it before this?
Is it alat yang untuk orang buah pinggang
Yeah.
tu?
Yes, for the kidney failure patient, okay. My late father was one of the patient for the kidney failure. The kidney cannot work anymore to filter your blood, okay, to remove the toxins, all right, such as urea and so on. So if the kidney fail, we need to use a machine, okay, to act as the kidney, a really big machine. Look at that, okay. God create us a really small kidney inside our body, okay. But if it fail to work, we need to use a really huge machine, okay. And then we to go there every day for every after every 2 days and so on, depend on the level of the kidney failure, okay, to filter our blood there, to remove the toxin from our blood. Okay, so using dialysis, we use a filter there. We also application of the separation technique. We use a membrane there inside the diffuser. We have a membrane, okay, to separate the blood, okay, and the toxins, okay, the residue, and the diffuse it. Okay. All right. So classification of separation methods based on type of phase. Okay. Table 1.3. So gas. Okay. Initial phase. If the initial phase is gas, oh sorry, I need to tell about liquid-liquid extraction. Okay. Have you done this liquid-liquid extraction before this? Can anybody give me the example? What is the process of liquid-liquid extraction? A really simple one. Using what? If you have, for example, yes, okay. If you have, for example, yes, Michelle, using a separating funnel, okay. In the water sample, you need to analyze the oil and grease inside the sample. So you need to put the solvent to dissolve the oil and grease inside the water, and then you shake the separating funnel so that all the oil will dissolve, okay, inside the solvent, okay, and then after that, after some yes, different in polarity. So the oil is non-polar, right? The water is polar, so we use the. So we want to dissolve. We want to extract apa nama ni, the oil which is non-polar from water is polar. So what kind of solvent that we're gonna use inside the separating funnel for the water sample? What kind of solvent? Polar or non-polar? We want to take the oil, not the water. The water is polar. Okay. What is raffinate? Okay, we will learn after this what is raffinate. Okay. From liquid extraction, so we use normally we use the N-hexane. So N-hexane polar or non-polar? Non-polar, right? So we need to take the oil, to dissolve the oil inside the non-polar solvent. So because of course the water is polar, so we need to put the non-polar solvent to extract out the oil. The oil is also non-polar. Oil and grease. Okay, grease is non-polar. So at the end of the liquid extraction, also of course we need to have 2 layers, right? To remove one of the layer, and then we take one of the interest layer. So that is one of the example. We separate funnel, okay, put the N-hexane into the water sample, okay, and then at the end of the process, after we shake the separating funnel, it will be in 2 layers. So we remove the water, and then we take the N-hexane with the oil inside. And then we remove the solvent, and then we can see on the filter the oil and grease inside the water sample. That is one of the example of liquid extraction. So chromatography, as you know lah, we have a lot of instrument in chromatography, HPLC, GC, and so on. Okay, so for gas, initial phase gas. For the second phase, if the second phase is gas also, vapor, so this is thermal diffusion. If the second phase is liquid, right, so we use gas liquid chromatography, right? If the second phase that we want is solid, so we have gas solid chromatography. So if the initial phase is liquid, and after that we want the second phase in the gas or vapor type, so what type of process that we need to have? Yes, distillation, Melissa. Okay, good. Okay, we need to distill. Okay, distillation. So we get a gas or vapor. And then if you want the second phase is liquid, we need to do liquid chromatography or liquid extraction, dialysis, ultrafiltration, and so on. If you want the second phase is solid from the liquid, so we do liquid solid chromatography, precipitation, okay, electrodeposition, crystallization, inclusion compound formation, okay, so on. So if the first phase is the initial phase is solid, and then we want the second phase is gas or vapor, we do sublimation. And then if you want the second phase is liquid, we do the zone refining, leaching. Okay. And then if you want the solid phase from the initial phase, which is also solid, you do the zone electrophoresis. Okay. So we have the driving force, right? That we have learned previously, mechanical, physical, or chemical reaction. Okay. So analytes in the mixture can be separated due to different in size, volatility, polarity, solubility, ionic strength, etc., etc. Okay. So what is classification of the driving of the separation techniques by driving force? Okay. For equilibrium, okay, we use chromatography, distillation, extraction, zone refining, sublimation, and precipitation. For the kinetic, we use dialysis, okay, zone electrophoresis, diffusion, thermal, centrifugation, ultrafiltration, okay, and so on. Right, so take 5, guys. You're already tepu right now, so take 5, have a coffee for a while, okay? 5 minutes.
Sorry doktor saya dah post pasal height volume tu dekat dalam group.
WhatsApp group kejap saya tengok. Take 5, take 5.
It's okay, okay.
Okay, welcome back guys. Ada soalan Doktor, between air solvent and canister, which one lagi murah dan bagus? Okay. Air solvent and canister, we have two different purpose. Okay. If for example, we gonna sample a gas sample at the one of the location, okay, dan kita tahu ada satu pencemaran udara, katakan ada gas toxic kan. If we don't know what type of gas there, so the first one is we need to use the canister. We put everything, okay, the sample of the location gas that are the case tu inside the canister, whatever it is ada dalam udara tu kita masukkan semua dalam canister. Then if we already know what kind of toxic gas or analyte, okay, inside the air sample, so after that we need to do, if you, let's say we want to do some measurement after that, how much of the toxic gas targeted, we already know. For example, VOCs, we have benzene, toluene, ethyl benzene, and xylene, BTEX. Okay, so we use a specific type of solvent that can trap BTEX there, because previously we don't know what type of gases, so that we use canister, right? Of course, both of them are mahal. Okay, but different purpose lah. Okay, what is the difference between cross current and counter current? Okay, we go back there. Nampak je sama kan? Kat mana current tadi tu? Okay. Cross current, the current of water, example, that flow against or across the main current. Counter current, a secondary flow that against or across the main flow. Okay. Macam sama kan? A current of water that flow against or across the main current. Okay, this is phase contact for cross current, and for the counter current, okay, a secondary flow that against or across the main flow. Okay, actually quite same, tapi kita akan tengok nanti dekat application ni baru kita punya definition so you bear in mind of this definition. So after this, when we go to the exact application of this phase contact, kita akan faham alright, so tak apa, bear in mind dulu, tengok dulu. Okay, so classification by operational aspect. Okay, analytical separation techniques, we have batch and continuous, right? For batch, we have offline detection. Okay, but for continuous, okay, we have non-chromatography, we have offline and online. Okay, and then we have chromatography, also offline and online. Okay, this is continuous application, continuous for the analytical separation techniques. Okay, what meaning by batch and continuous? Okay, for example, for batch, you have one sample, then you analyze, you get the result, done. Okay, and for continuous, for example, after the Sungai Kim Kim incident, okay, air pollution by incident by the illegal chemical waste dumping at the Sungai Kim Kim, and then contribute to the sparks of the air pollution. Then to monitor continuously there on the toxic gases at the Pasir Gudang, the government have installed several probes there. For example, the detector that use the infrared technique to detect the toxic gases there, the permanent one, continuously recording the air quality at Pasir Gudang. And then we have also the portable GCMS, okay, that analyze the air continuously to detect any toxic gases inside the air, and both of them can be online and offline. For non-chromatography, for example, I told you using IR technique, spectrum, okay, spectroscopy technique, okay, it can be offline, okay, also can be online, okay. So that the probe, the sensor is there at Pasir Gudang, but the Department of Environment officer monitor the air quality is at Putrajaya, but the probe is at Pasir Gudang through online, okay. Similar with chromatography technique using GCMS continuously analyzing the air at Pasir Gudang. It can be offline and also online. Okay, that is a very latest technology that we have lah. Previously kan mana ada online untuk kita nak tahu. You kat Pasir Gudang, you kat Putrajaya, you can monitor the air of Pasir Gudang using GCMS. Okay, but now we can, right?
Sorry doktor. Doktor nak tanya.
Yes, Afifah. Yes.
Continuous dengan batch ni, continuous ni in terms of time Continuous in time, batch tadi doktor kata batch tu.
Sample lah, sampling, to separate lah. In this case, for the operational aspect, for the separation lah. Okay. For example,
Okay.
batch, we have one sample, we analyze the sample, done. For continuous, like I said to you, I give the example air. We monitor the air every day, 24 hours, 7 days per week. So it is continuously. So for the separation that using chromatography, we are using GCMS. So the air is being sampled continuously and separate inside the solvent continuously, okay, directly inside the GCMS, continuously, non-stop, right? For batch, you have one sample, you analyze, you get the result, done. But why you need the online for batch sample, right? Because you analyze, then you have the result. So why online? No need online, right? But for continuous, why online? Because if let's say something that you need to monitor continuously, so you need to know it real time. You know what is real time? This is the words that you're gonna use, always gonna use in industry, real time monitoring. Meaning that right now, what happened in Pasir Gudang, you can just monitor using your screen. That is real time, right now. Okay, for batch, so you don't need online because you have one sample, you analyze, you get the result, done. Right? Understood, Ifah?
Understood. Yes.
All right.
Okay, doktor.
So separation method, okay? We have mixtures, okay? Solid mixtures containing magnetic materials, for example, and then separate by magnetic attraction. We have a mixture of, let's say, a magnetic material and non-magnetic material. So we separate using magnetic attraction. That's example. Okay, so we have solid liquid mixture containing insoluble solid and soluble solid. Okay, if insoluble solid separated by easy lah, kita filter sahaja. Filtration. If it is soluble, which we both of the solid that we want is dissolved in the liquid, so we need to do decompose. Do not decompose on heating, okay, and also decompose on heating and separate by either evaporation and crystallization, okay. And then we have a liquid mixture. So like I say, that using separated funnel example to separated into a liquid and its mixture by distillation. All right. Also different liquid and their mixture by fractional distillations. Right. This is commonly used in oil and gas industry. Right. Different boiling point. Kan dalam crude oil tu. Remember, we learned this thing since SPM, right? From the crude oil, we have different type of compound inside it. We have a petrol, diesel, kerosene, bitumen, and so on. And all of these things have different boiling point. So this is example we distill. We're using fractional distillation and so on. Right. So different colored components. So you can be separate by chromatography. Right. Understand this table. Really, easy to understand this table. Okay. So let's say now we have an oil spill again. Okay, this oil spill happened. Okay, at the open sea. Let's say this is Selat Johor lah. Okay, then you see there a lot of tumpahan minyak there. Ada yang terbakar lagi kan. Well, crude oil boleh terbakar kan. When we put some ignition or spark there, the crude oil will burn. Okay. Alright. This is I'm not doing this in group lah. So we do now lah in class together. Okay. In class questioning time. Okay. How to separate mixture based on 3 pictures? Sea, soil, suit from Gulf Mexico disaster. Right? Right? We have this water. We have soil there. Okay, soil and sand. Okay, then we have smoke. So our analyte is hydrocarbons now. So how we're gonna do this physical separation? Okay. For this one, water. This one, what? Solid sample, kan? And this one is gas sample. Okay. Right now, okay, macam mana? Kita nak buat hydrocarbon ini. Kita nak now we have what? Liquid, right? Am I true? Our hydrocarbons consider liquid or what? Liquid kan? Oil kan?
Yeah.
And then our sample also liquid kan? Seawater kan? So how to do separation? Volunteer. How to do separation? Like my example before this lah, I said to you. Macam mana? We want to take out the hydrocarbon from the sample, from the seawater sample. So how we do? Volunteer? Okay. Liquid attraction kan? Won. Siapa cakap tadi? Using separating funnel. Pak Vitran pun cakap liquid attraction, betul. Collect the oil on surface. Yes, we can collect the oil on the surface, but there it is still mixed with the seawater. Okay. Woon, betul. Pak Vitran, betul. Okay. Michelle, okay. Liquid attraction. Okay, right. So now how we want to do to separate the sample, our analyte from the solid sample, which is the soil or the sand. How are we gonna do? What is our sample? Our sample is what? And our analyte is what? In what phase? And our sample in what phase? Our sample is and our analyte. Our analyte is the hydrocarbon. Okay, the oil. Okay. SLE. Okay, solid, liquid, extraction. Right? Okay. Okay, now how we want to do the extraction for this sample, the gas sample. Okay. Michelle, filtration for this sample, air sample for solid. Okay. All right. So now we have a gas sample. So how we separate the sample? Our analyte is the hydrocarbons, the volatile again, organic compounds. Gas liquid chromatography, right? Also can. Okay, apa lagi? Based on the chart that previously showed to you. How? How to do physical separation? Gas extraction. Okay. Okay. Boleh collect particulate. Yes, also can. Okay. We can collect the particulate. Thermal. How to do thermal?
Because different they maybe have some incomplete combustions of the hydrocarbons, maybe got different size density can use in thermal.
Yes, also we can because it is crude oil, right?
Yes.
All right. Okay, good. Okay, good, everyone. So the IUPAC's the definition of the chromatography, okay, a physical method of separation in which the components to be separated are distributed between two phases, okay, one of which is stationary while the other move in a definite direction, okay. We have two phases, okay, and then we separate. One is stationary and one is moving. That is the meaning lah, right, of the chromatography. So this is a principle. Okay, we refresh the principle of the chromatography. Okay, we have the flow of mobile phase. Okay, we have detector. We have a mixture of a compound there. Then we separate. Okay, we have most and we have least. Depend on the type of the what stationary phase, right? The compound will interact with the stationary phase. Let's say our interest is the polar and non-polar compound. So our stationary phase now is polar. So what interact most with the polar stationary phase? And what least interact with the polar stationary phase? Remember the principle in the chromatography. Polar love polar, right? Am I true? So what most interact with the what is the compound most interact with the polar stationary phase? Is it a polar compound or non-polar compound? Polar compound. Okay. And what interact least with the stationary phase is non-polar compound. Am I true?
Yes.
Okay, good. Okay, class. In my class, sometimes I would say a wrong concept. So that I would like to know, do you notice it or not? Okay, you can argue me. Okay, doctor, that is not true. Yes, you can argue me, right? In our next class lah, I will. You can argue me. Okay, doctor, that's not correct. For me, I think this is the concept. Okay, you can do that. Okay, we are in two-way interaction class. Okay. So this is traditional separation methods. We have sedimentation. Okay, what is sedimentation? It relies on the variation in the density between material to be separated. This process is often used in crystallization of pharmaceutical, okay, wastewater treatment plants using this method. Okay, you know the wastewater treatment plant at the college KRP, KTF tu, ada kolam belakang kat Tasik tu kan. You know that? Right? That is oxidation point. All your waste will go there. Okay, all your waste, okay, you stay inside and all your waste will go there, okay, and will be separated through sedimentation. Your heavy waste will sedimented, okay, at the bottom of the oxidation pond, and then your lighter waste will flow, okay, to the Tasik. Then you mandi kat Tasik ke? Alright, so that is the concept of oxidation pond, okay, using sedimentation concept, use gravity only, okay. We also use centrifugation, okay, ada pusingan kat situ, okay, dengan sangat laju, okay, centrifuge, okay, and centrifugation is similar to sedimentation using also forces, okay, kinetic forces kan, right? Although it create larger forces using high angular velocity rotating units. Bila they rotate, it will create larger forces. Denser material move towards radially outward. Okay. Faham centrifuge. Pusingan tu. Kelajuan tu akan menyebabkan denser material tu akan pergi ke bahagian yang paling luar dalam compound tersebut. Sebab dia berat kan. And then we have that traditional separation method as well, colloid precipitate flotation. This technique involves creating a colloid containing a specific species using a coagulant and surfactant to stabilize the colloid. The coagulant which form the colloid binds to one solute, but not the other, which creates the partitioning. Okay. All right, and then the colloid will be less dense than the solution, and the difference in densities cause the colloid to float where it can be collected off. All right. Right, so we have also advanced novel separation. Yes, like detergent also. Yes, detergent it involved in the hydrophilic and hydrophobic concept, right? The hydrophilic will trap all the contaminants or the pencemar. Hydrophobic, and hydrophilic part of the detergent will hydrophilic part will attach with the water molecule. So you can remove the oil and grease pencemar dalam pakaian kita, and then like surfactant is also one of the ingredient in detergent lah. The concept is quite similar, hydrophobic, hydrophilic. Okay, hydrophobic, hydrophilic. Okay, so what is the advanced separation method? We have magnetic separation, electrically driven separation, moving membrane system, liquid membranes, chromatography separation, lab on chip, and so on. So this is the example of high gradient magnetic separation. Okay, rely on the ability of magnetic field to attract the diamagnetic particles and then repel paramagnetic particle. Large magnetic field gradients are used to obtain higher separation factors. This method can be what is lab on chip? Michelle, lab on chip is I also don't know lah. We will look after this. Okay, it's quite if you know capillary electrophoresis. Okay, and also we develop also a simple separation technique using a small chip, okay, like capillary electrophoresis. We will learn after this, okay. A small device that can separate the samples, okay, that we call lab on chip. We will learn. This is application of the capillary electrophoresis, okay. All right. So this method can be used, the magnetic method can be used to separate heavy metals, radioactive waste in a slurry form. Water slurry form macam it's like quite liquid but in form of slurry lah. Water purification and the separation of blood, soil and water mixture is slurry, selut. And the separation of blood reduce and methemoglobin are paramagnetic while oxyhemoglobin is diamagnetic. So this is really advanced method lah. Right, gradient magnetic also we have a gradient magnetic technique in advanced novel separation technique. Okay, right. The gradient magnetic separation method depends on the bacteria or cell that have been magnetically tagged. All right, tagging can be done using antibody antigen, a binding recognition where the antigen is attached to the ferromagnetic particles. Bands on functional group. Then the antigen bind selectively to their antibody counterpart on cell or bacteria, which can then be separated in a magnetic separator. Wow, this is really advanced lah. Also, we have capillary gel electrophoresis. Okay, this is a combination of CE, capillary electrophoresis, and size exclusion chromatography. So we have inner bore filled with gel, we have resin coating and fused silica. Okay, this is a capillary. Okay, and solutes move through the capillary due to the electrophoretic mobility. However, the gel slows down the larger species. So it combination, okay, of CE and gel electrophoresis. Okay, the solute moves through the capillary due to the electrophoretic mobility. However, the gel slow down the larger species, right? This technique can be used to separate species with similar charge to size ratio, okay? But different size, okay? We have a species that we're going to separate which have the similar charge to size ratio, okay? Charge dia sama, lebih kurang. Ratio charge dengan size dia tu. Kalau kita guna gel kalau kita guna CE, capillary electrophoresis, dia akan tak separate lah. Sebab charge dia sama tapi size dia berbeza. So kita combine dengan gel, capillary gel. So yang larger particle tu akan jadi slower. Okay. So that the similar charge particle but different size tu kita boleh kita boleh separate. For example, DNA and other oligonucleotides. Okay. Okay, and then we have also a new millennium in separation science based on the microfluidics and also microarrays. So this is lab on chip. It also application of the like I said previously, capillary electrophoresis. Okay, lab on chip, a concept for capillary electrophoresis. Okay, we have sample input and dilution buffer. Everything is on the chip, right? So chemical reagent. Okay, and then it move on the chip. Okay, we have a sample channel, we have a separation buffer, okay, and so on. Everything is on the chip using a really small amount of reagent, buffer, and also sample. Okay, Michelle, understand? It's really small scale of analysis using a really advanced technique the application of the capillary electrophoresis technique. All right. Right, LOC, okay, that one chip. The term for device that integrate multiple laboratory function on a single chip of only mm2 to few cm, okay, in size, okay, mm square to few cm square in size, right? Capable of handling extremely small fluid volumes down to less than picoliter, okay, really small, pico, not nano, pico. LOC fabrication process is lithography, use chemical process to create an image, right? Lithography is structuring material on a fine scale. This is an example of microchip electrophoresis. We have a metal line, glass, and also electrophoretic channel. We have an exit channel there, okay, inlet channel and exit channel, right? Can be made using lithography methods from microelectronic fabrication. Microfluidic techniques for fluid handling are combined with voltage supply by metallization of lines. Right. So this is about the market size of the separation technique. Really big, right? It's $1 million, right? Electrically driven system, moving membrane, chromatography, magnetic, liquid membrane, and so on. Total out for about 1 billion. Okay, for 2000. Almost 3 billion for 2005, right? And then the average annual growth rate, all right, is about 23.4 million, okay, for 5 years. Really big, okay? The application of the separation techniques in the industry is really big, okay? It's about billions dollar. Right, this is total US expenditure for the reagent used in different chromatography techniques, okay? Look at there, okay, for combination of the techniques, okay, 2000 to 2007, increasing, okay, from 1 billion to about 3 billion, okay, average rate of AAGR, okay, growth rate, this is about 11.7%, okay, source from BCC Incorporated 2002, all right. Okay, we can see that a really, really big market in the separation science, separation technique, especially in chromatography industry, right? This is the market size, okay? The demand is really big, okay? So why we need to learn this? Because it's really, really useful and being applied elsewhere. A lot of application of this technique, of this knowledge outside there, okay? So read to learn, read to analyze everything about established separation methods, studies on principle and application, interesting studies, non-library studies, and so on. You can also search for journals, okay? we're gonna have some assignment after this also to learn the for you to know about the you know, most advanced studies about these techniques nowadays, okay, and so on. Okay, that's all for our class. Sorry for taking a longer time. All right, 5 minutes extra, so about 10 minutes, 10 minutes extra. So thank you for that. I think that you don't have any question yet, right? All right, thank you. If you have class after this, I'm sorry. Okay, so see you in the next class. If you have any questions, you can always ask me in the WhatsApp group, and Dr. Afiq is also there. So this class is recorded. So I will my style is I will upload the video of my class in the YouTube and I put it in the e-learning. You can watch it again after this. All right. So thank you. See you again, and bye bye. For Muslim, you can read the prayers after the class. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asr innal insana lafi khusr alladziina amanu wa 'amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr. Thank you everyone. Bye bye. See you again.